Foundations of Amateur Radio. When you spend some time in this hobby, you're likely to find equipment with similar performance for vastly different pricing. At one end of the spectrum, you might compare a cheap $25 handheld radio to a $450 one. At the other end, a $1,500 SDR or software-defined radio against a $4,500 one. Those examples are for brand-name devices, which generally speaking have published specifications, come with regulatory approvals, a wide user base, reviews, and a distribution network. If equipment is found to be operating out of specification, a regulator might seek a remedy or ban the sale of the equipment. Those various sources and processes make it possible to compare those devices in a structured way, to discover just how deep into your pockets you need to reach in order to acquire a shiny new gadget. If you buy any of these devices in the used market, you have no way to determine just how far from the factory specifications the device you're contemplating has deviated. Is that waterproof radio still waterproof, or did the previous owner open up the case and put it together incorrectly? Was it dropped and did a component get damaged? Did the static electricity from a local thunderstorm leak through the circuit via the antenna, or did the previous owner not use anti-static precautions when they looked inside? If it actually failed, it's easy to know. If it's still working, absent a laboratory, you're essentially on your own. If that's not challenging enough, consider hardware that's released as open source. That is, the original designer released their project, shared the design as circuit board with component list and specifications. Another person can pick up the documentation and legally build a copy of the hardware. How do you know how the two compare? Aside from considering how well any design might actually match the real world, how do you know if the original design can be improved upon or not? Did the second builder use the same components, substitute with better ones, or economize on parts they thought were too expensive? What happens if the two designers argue with each other about the performance of their respective designs? What if the second design becomes vastly more popular than the original? And what if you throw in outright intellectual property theft over the top of all this? Now consider the same physical hardware from the same factory, but using different software. How do you know what impact the software has on the performance of the equipment? For example, one component seen more and more is a chip called an FPGA, a field programmable gate array. Think of it as a programmable circuit board where updating the software creates a different circuit. An FPGA might be used to filter radio signals. With just a software update, you can program different filters and change the actual performance of the entire device. How do you know if the new version of the software has improved or worsened performance? What all this lacks is a standard way of describing performance. Not only the kind of standard that's achievable in a laboratory, but one that we can test at home. There's no documentation that I've been able to find that shows how to measure some of this objectively, or even compare your own kit against itself. It would be great if I could measure my gear against a standard, and you could too, and we could compare our respective equipment against each other. Even using the laboratory standard measurements, for example the Sherwood Engineering Receiver test data, which allows you to compare other tested equipment in the same list, is hard if not impossible to compare at home by the likes of you and I. Not to mention that Rob, November Charlie 0 Bravo, has finally retired after 45 years, so having been licensed in 1961, age 14, there is a good chance that updates are going to become a thing of the past when Rob stops volunteering his time. I will mention that this isn't a new thing. Many years ago, I spent some time as a broadcaster. One of the very first things I was taught is that you need to set levels to trigger the VU meter just so. When you make a recording to tape, you're required to generate a 1 kHz tone at a specific level, so when it's played back to air, the voice levels will be correct. When I became licensed in 2010, I almost immediately discovered that there isn't even a standard way to test if the signal that my radio is putting into the local repeater is the same as that of other amateurs. You'll notice this because you're forever twiddling the volume on your radio when you speak with others on air, because their voice levels vary widely. One idea I've been toying with is using a parrot repeater that can measure a signal, allowing anyone who uses the same parrot to compare their equipment. How would you approach this increasingly complex problem in such a way that the amateur community can share their results in a way that makes comparison meaningful and useful? I'm Ono, a Victor Kilo 6, Foxtrot Lima, Alpha Bravo.